So we get started, I think, because we're already 20 of us, of all the people who subscribe on the Meetup group. Thank you so much for coming. My name is Adrian Kosmaczewski, for those of you who might not know me already. Not again. Yeah, it's me. I'm sorry. I'm from Vision, the DevOps company, and we organize this CNCF Switzerland chapter Meetup every 3 months. Okay, so thank you so much for coming. Today we are in ServiceNow. Thank you so much to Jean-François and Dennis for the warm welcome, as well as Gabriela, who basically set up the whole room, and it's fantastic. Everything looks beautiful. And then we're going to have, at the end of the 3 presentations, we're going to have a very nice apéro. So please stick around. This is an advantage for those who come, not for you watching on YouTube. And if you haven't subscribed yet to our YouTube channel, it's vision.tv. VSHN.tv. Please, you have 5 minutes to subscribe on your smartphones. No, I'm kidding. Let's not do that right now. So, with you, Jean-François from ServiceNow.
Thank you so much. So I'm your host today. So from my side, first of all, thank you, Adrian, for organizing this stuff. Really cool to have such a community and being able to speak here. So my name is Jean-François Muller. I usually go for Jeff, because it's much easier to say as Jean-François. I run the technology workflow solution consulting organizations at ServiceNow for EMEA Central. And I'm really glad to have you all here. We have a couple of great speakers today, including my colleague Dennis, which is going to talk about OpenTelemetry. So a couple of things, just we are going to stay here for the presentations. The apéro is 1 level below. Same place here in the ServiceNow office. I've organized a lot, so I guess I can feed you twice, probably. There are some beers, drinks, whatever you want, wine. Happy to have you there. It's a great time to connect and to have some interactions, so please use it. Today is a little bit special because the brand we are looking to promote today is not ServiceNow, it's Lightstep. It's a solutions ServiceNow has acquired 2 years ago, and which has been designed for cloud-native people like you. It has been designed by cloud-native people for cloud-native people, and it's going to talk. Well, the talk is about observability, so you probably heard about this one a couple of times. And my colleague is going to talk a little bit more about, let's say, the instrumentation level and so on, and OpenTelemetry. A couple of words from my side. So, what is Lightstep? So where it is and where it comes from. So as I told you, has been acquired by ServiceNow 2 years ago. Where it comes from, it's a solution that takes its roots in Google. A couple of years ago, one guy, which is called Ben Ziegelman, alongside with other people, these guys are behind stuff like Monarch, if you heard about Depper at Google. Also, another founder is coming from Twitter. And these 2 guys, back in the Google days, they started to think about instrumenting code in the cloud-native world. And at the beginning, they founded something which was called Open Tracing, which was a couple of years ago, I think, yes, in 2016. Ben co-created Open Tracing, which was an initiative looking at instrumenting the code to get distributed traces within the cloud-native world. In 2018, Google started another initiative which was called Open Census. I don't know if you heard about. It was an initiative oriented on, I would say, measuring, I would say, things around resources and response time, such kind of things. And a couple of years later, in 2019, they decided to merge and to create something which is called OpenTelemetry, which is becoming slowly, I would say, the standard in that world. And Lightstep obviously is a solution that takes advantage of OpenTelemetry alongside of other solutions on the market. You're going to hear a little bit more about OpenTelemetry with Dennis, which is going to go through a demo. So what I wanted to say about Lightstep, so I'm sure all of you have faced these situations where you push some code in productions and something doesn't work like expected. So you have performance degradations or something not working as expected or whatever. Lightstep is focused on answering these questions. What caused that change? What happened? You know, this world is quite dynamic. You have lots of containers going up, down, and so on. It's quite difficult to find out the root cause of issues. And Ben created these solutions really to focus on helping people like we are to address such kind of challenges at scale. That's really important because, you know, I guess we are all the same. When we create an applications, we expect lots of usage. We expect lots of people going and using our applications. But then the problem is volumes, right? You start to have lots of data, lots of metrics, and so on. And dealing with such an amount of volumes, I'm sure you know that it's quite challenging. And the focus of Lightstep was really to handle such kind of use cases and kind of issues since the beginning. So yeah, it's, again, this event is sponsored not really by ServiceNow, but more a Lightstep event. So we wanted to, let's say, talk about a little bit and let you know about these solutions. The only ask I have is if you have any observability initiative in your own environment, just consider these solutions because I really think it's a hidden gem and it's worth to have a look. That was it from my side. And we are going to go to something much more interesting, the demo. Thank you.
Can I?
Yes.
Does it work?
Yeah, absolutely.
Oh. Yeah, but it doesn't work here.
You have to click it. That's it.
Oh, yeah. That's right.
Yeah,
Good.
okay.
All right, so my name is Kuipers, and I'm in the team from Jeff, so we're working quite close together. We know each other from a long time, since the day of Wiley and Precise. Maybe for the people that living that long like us, those are the first APM tools of the market. So he was basically my competitor, but now we are friends today, so that's very good. And we are very happy together right now because we have the same passion, right? All right. So for the demo, I just basically prepared an environment for the demo. It runs in Azure. The reason for that is that because I have an Azure account from ServiceNow. So quite easy. You just spin off a Kubernetes cluster, all done. Not that much difficult. Inside the Kubernetes cluster, I have the boutique application. Why? Because I'm too lazy to write my own application. So, you know, for demo purposes, it works perfectly. That boutique service does have multiple services, microservices, in different languages. So maybe you guys are familiar with it, but it has Golang, it has Java, you know, basically all the different languages. So what we're going to do is basically instrument those microservices with OpenTelemetry. Who had worked with OpenTelemetry so far? Oh, that's very good. In which language? Different languages. Okay. So anyway, so what we're going to do is we're going to instrument those different microservices, and then we're going to send using an OpenTelemetry collector to Lightstep, where I collect basically all the different traces, logs, and metrics. And then, of course, you know, you can send it to any backend, but what we like to do with Lightstep is to collect any, well, let's say, every transaction, every traces that runs through the microservices in Lightstep. So we're not going to summarize it or we do averages, but every trace that runs through the different microservices, we will have it in Lightstep. The rest of the architecture, well, that's for another use case. We're not going to explain that. So what we're going to do is, first I'm going to show you what Lightstep is all about. How does it, shows you the data, how does it do the analysis, and so on. And then I go into kind of the instrumentation part, you know, from an automation point of view, because you can instrument in two ways, manually and of course through an automation, automated. And then I will show you the collector configuration. But maybe for the people that are already familiar with this, they maybe recognize it. I'm a Java, C# kind of experienced guy, so I do it in C#. So apologize if you need to do it in Golang, but you know, sometimes you need to kind of be flexible. Okay, so.
The cloud is polyglot, so as long as it runs in a container, you're good to go.
Exactly. All right, so just to show you, this is my Azure environment. It does have all the workloads, as you can see here, and basically you can see the different microservices, which comes from the boutique application. So, as I said, we basically instrument them all, and we send the information to our backend in Lightstep. So when we go into Lightstep, then you can see kind of, you know, all the different microservices, and you can see the different key operations that we have instrumented. So with OpenTelemetry, we do three things. We look at latency, we look at rate, and we look at errors. That's those three key metrics that we collect. And that's where we basically do the analysis. So if you look at the next step is, what can you do with Lightstep? And because we have all the data from the containers, we can basically build easy dashboards. I mean, that's not very difficult. It's basically a query against our backend, and then it basically, you can configure any type of dashboard, any type of metric that we're collecting, and you can put it together. So what we like to do is, first of all, kind of the overview. So how does the microservices perform, but also give you the possibility to analyze. Not that like in the early days where we had, for instance, an APM tool where we see the instrumentation and we see the kind of the response time, and then we need to find out the CPU usage in another tool. With OpenTelemetry, we now have it all combined together, so that's a kind of a benefit. So what I want to do now is, when I look at the CPU usage of a particular microservice, I want to analyze it. And I don't want to spend too much time in an analysis, because you know, I'm kind of a lazy developer, so I like to let the tool do the work. So what I like to do is just click on the peak and ask the tool to analyze it for me. So what happened now, I need to go in the change. So what we'd like to show you is basically which of the attributes are contributing in latency, or in error rate, or in normal rate. So you can see here that we compare everything with a kind of a baseline, which basically you can set here. So I was basically moving around a little bit. So what I'm interested in is to compare an area which has normal response time with an area where we see the peaks. And then in the back end, we try to analyze all those attributes, traces, and so on. So as you can see here, there are some contribution from an attributes point of view. And when I open this one, it will show me all the traces. So all the little dots here are traces. As I said, we're not throwing things away. We keep the things. So every single trace or spam will be collected in our backend. So that means that we can easily find out that you can see here, there's a couple of traces that really jumps out of the baseline. And of course, the next step is you want to do is to see, you know, how the trace looks like. And there's where you go into the kind of the instrumentation layer and see, you know, which part of the trace is contributing in the response time. And as you can see, I created my slow function just to, for demo purpose of course, just to slow down the app. So as you can see, my slow function is basically the root cause here. So in 2 or 3 clicks, I went down from a CPU metrics into kind of a code analysis. And that's basically the benefit of doing OpenTelemetry. And there are more benefits, but I'll explain later. Any questions so far? No? Everything clear? Because my boss always said that I sometimes speak too fast. So, yeah? Understandable? That's very good. Right, so how does it work? And as I said, we have 2 types of instrumentation, automated and manual. And that's where I go into the next step. So let me go into my programming stuff. When I saw OpenTelemetry for the first time and they were speaking about automated, I was thinking around Java agents that doing all the instrumentation. But that's not the case. Automated basically is libraries. So in this case, you can see here as well that for C# you just have 4 libraries that do all the instrumentation on the main classes, right? I mean, all the entry points, they basically instrument. So this is basically auto instrumentation that you will get from a C# point of view. And of course, every language has its own set of libraries. There's one exception, Java is still doing the Java agent. I'm not sure if you have looked into it, but Java is still doing the instrumentation with a Java agent. Of course, when it comes to attributes and that kind of stuff, you still need to do it manually. So as you can see, just a couple of lines. As part of my service, I can instrument the whole microservice. And of course, when this microservice runs and it makes a connection to another microservice, which is also instrumented, then everything will be correlated together. So you have your own stack. So as you can see, it's not much to do. And you know, those 4 libraries, of course, you can configure them, you just can filter and stuff. There's more options, which I'm not going to go into it. But this is very powerful. And of course, the benefit of doing this is that today I can send the information to backend like Lightstep, but tomorrow I can say, no, I'm going to use Jaeger today. Because I can easily change the backends if I work with OpenTelemetry. And that's basically a benefit. Because OpenTelemetry is basically a framework. So every backend understands kind of the data that we send over to them. And that makes it very powerful and flexible. And also for us, to replace some competitors, make it also very flexible. Anyway, that's another thing. So this is basically the automated instrumentation. And when we go into the more manual one, then of course you need to do a little bit more effort. Where is it? Is this the right one? Yeah. Here. So here, so as you can see the source activity, start activity, and this is basically kind of the lines that I need to put in. And this is coming from the source, and the source is basically defined on a global level here. So that means that when the automated instrumentation took place, it basically sends it over to this source. And from there, I can basically hook in any type of manual instrumentation by just adding those lines, which I where is it? Which I showed before, here. So as you can see, it's kind of, well, it's not much effort, but of course you need to put it in. The second thing, what you can see here as well, is the add tag. And this basically are the attributes. And from my point of view, that's a very good, nice feature from OpenTelemetry, because you can do a lot of analysis around those attributes. For instance, for OpenTelemetry, when you use Kafka, they do this automatically for the partitions, the topics, and so on. So I can look at the data from a partition point of view or from a topic point of view. And that makes it very, very powerful from an analysis point of view. So as you can see, there is some effort to do, but once you have put it in, and you have set your collector, it works perfectly. So the previous one was the automated, this is the manual one. But if I go to the collector itself, so this is the deployment. So it's basically using a config map in the cluster. And here in the config map, you can do a lot of filtering. Where is it? Here. So in the config map, you basically defined your exporters. And as you can see, I'm using one exporter to Lightstep, but I can set up another export to another tool. So that means that I don't have to send it over to one particular tool, but I can send out to different tools, because I only have to define a new exporter. And with the traces here, it allows me to do also some filtering if you want to remove some data or whatever. So the collector does do more than only being in gateway. It also allows you to set different exporters and send it over to other tools as well. That's it from my demo point of view.
Yeah.
So
maybe just one thing I wanted to mention about this one. So the really cool stuff here is, you know, OpenTelemetry doesn't there is no vendor lock-in. So if you
the microphone.
Sorry.
Otherwise, nobody will hear you.
I take. Oops. And one of the things I wanted to mention is the fact that OpenTelemetry is, I would say, something you should definitely consider when you do something, because you don't have any vendor lock-in. We're just presenting stuff around Lightstep, but I mean the cool stuff is about you put OpenTelemetry, and then after that you just decide what kind of backend you're going to use to analyze stuff. So, and if you're not happy with one solution, nothing prevents you to move to another one. It's quite easy. It was the piece that Dennis showed at the end, just changing the collectors. You can even, you know, in a POC, decide to send the same data to two different solutions, and then to compare how effective one is compared to another when it comes to the analysis. And I think it's really a fantastic stuff, because I was talking to competitors, an Austrian competitor which is doing an APM solutions, and he told me it's really interesting for them as well, because they spend lots of money in developing their agents to collect the data. I mean, with this approach, we are going to have something which is standard to instrument our code. And then, you know, they can focus on what brings really value. It's not collecting data which makes value. It is how we analyze it and how things are presented to the people so that they can be effective. You know, instrumentations, collecting data is legacy, I would say. And especially if you think about things like OpenTelemetry or eBPL stuff, it's really becoming standard. So thank you so much for your attention. One thing I wanted to mention is, if you want to play with the solutions, no engagement, there is this sandbox stuff, so you can go there, just /sandbox. You can have some guided tour around the solutions. And I mean, my only ask, if you enjoy it, just consider it in any observability evaluations you may run, and have a look on Lightstep, because it's quite a nice solution. Thank you so much.
Time for questions. So I don't know if there are questions from the audience. The only thing I would ask is if you can repeat them on the mic. If there are any questions.
Yes, I will do.
I don't know if somebody would like to ask a question. Yes.
The config map is still the configuration for the sidecars you inject into the pods?
Yes.
Is it still like this?
Yeah.
Yes, just repeating the questions. The question was if the config map is specific for the sidecars. It is.
It is.
Yeah.
And talk. And we have a new member who doesn't need to meet up, our special member for today. Any other question?
I have one. Because today, a few hours ago, what I was doing is in Istio, which is a service mesh for Kubernetes. I was configuring some auditing, and basically the documentation, they say that right now OpenTelemetry is the default kind of auditing, but from what you said, it's more like for metrics, not for audits, right? So
no, it's not for audits.
Please. Oh, microphone.
So the question was if OpenTelemetry is for auditing, And I said, no, it's not for auditing.
So you can't have any like debug logs from policies in Istio, whatever they're like.
If you're able to collect the logs, I mean, you can get maybe some auditing out of the logs, but basically the logs are basically used for getting kind of association between difference in behavior and the metrics and the logs itself. So the logs will be used more for kind of enrichment to analyze the problem, right? So if I see an increase in a particular response time, and I can see at the same time some log complaining about users are not able to log in, then you find a correlation. And in this way, you basically want to use this kind of data. But I think for auditing, I think the next speaker will probably have some more things to say.
Thank you.
Yeah.
The metrics you have shown in your demo,
Yeah.
is it still the combination of promises, adding
Yeah.
the data to the sidecar, sending them? Is it
Yeah.
still like that?
Yes, it's still like that, but we can also kind of do it straight from the container.
Yeah, the question was if the metric we've seen in the dashboard is coming from promotatives.
Yes, it is. But we can also do it differently. But that requires, of course, some more agents that I probably need to deploy. But if Prometheus is there, then I should basically get it from there. Anything else?
Good. Excellent.
Thank you
so much.
Thank you.
Thank you.
So I'm a bit worried because I spent so much time trying to shorten the PowerPoint because I've only got 30 minutes, right? It's not going to be a whole PowerPoint show. So good afternoon all, nice to see you all. My name is Claudio Serrano. I work for SUSE, as you can actually see from the little logo. I hope everybody knows what SUSE does. Everybody uses SUSE / in their environment, you know, Rancher, all that sort of stuff, okay? So, I'm actually, I don't know, Jean-François is gone actually, but you know, he stole my thunder because part of my demo, I'm not going to try to bore you with PowerPoint for too long, but I've got about 10, 15 minutes. Part of my demo also uses the boutique application, right? So he stole a bit of my thunder before. So what I wish to talk about today is really about security vulnerabilities within the Kubernetes context. So, and this is not just about detecting Kubernetes and container vulnerabilities, but also how protecting something that you don't know that is going on in your environment, okay? Potentially going in your environment. So, when we talk about Kubernetes, security in general, I like to think that we can start considering a couple of points, right? So first of all, you have the cluster itself, naturally, ensuring that the cluster itself is patched, is up to date, the configuration is done right. Also, of course, the supporting operating systems and nodes before also are being patched correctly. And of course, containerized apps are pretty much everywhere. That's why I guess you're all here as well. It's becoming very, very crucial for customers or for companies to actually start protecting their respective workloads, yeah? And of course, it's become a prime target. Okay, that's normal today, right? If you have CVEs out there, and then you potentially have an attack service inside your Kubernetes, you're exposing your Kubernetes API in order for possible unauthorized people to come in and do damage. Number one, unauthorized people, number one, and also attackers to come in as well. But this cluster security topic is a little bit boring because it's been going for about 2-3 years now. And of course it's important, once again, your infrastructure is secure, everything's okay, before we go on to the main topic of your applications and the respective application containers. So this is what I'm going to actually talk about today. Once again, it's a few slides, but it's important for me to give you the context in order for you to see what I'm going to show in the demo, yeah? Within this application security context, there are usually two things to consider. So the first line of application security is securing the actual supply chain. I think a lot of people are developers here, okay? Probably most. Yes, no? Is everybody asleep? No? And so what does this mean? Making sure that when you're building and deploying your software, that there are no known issues itself. And secondly, and possibly, you can consider just as important, if not more important, is the actual runtime security. So these applications are in production. How are you going to actually protect these applications? What's going to happen if a new CVE comes out while the application is running for the next 2-3 months, for example? It's been going there for a while. How do you actually can know that an application has a CVE in there that there is no patch today, right? So obviously you need to know that your application is vulnerable, is a chance to be vulnerable, okay? I'm going very quick. And of course I'm going to talk about NewVector. Number one, because SUSE acquired NewVector last year, right? Before it was a publicly held company. So I know a little bit about it, so that's why I'm here talking, I hope. And of course, naturally, it's not the only, container security tool, and of course, there's other tools out there, Aqua, Sysdig, StackRox from OpenStack, right? And which have their own merits as well, okay? So we're not the only people in the field. And another reason for it today is that NewVector, and if you don't know, is completely open source now, okay? So basically, this project has been given to the CNCF under the name of Zero Trust. I think it's the name of Zero Trust. So if you're all happy with what you see, go back, download it, install it, and off you go. Okay? The code's exactly the same. It doesn't matter how we make money, but we make money somehow, but we not make money from the actual software itself, okay? For the ones that don't know, SUSE makes money from subscriptions and support at the end of the day, right? So let's go back to the 2 layers of security of your applications. Okay, this is I'm not going to do the fancy stuff. I'm going to show everything on here, and I'm going to talk about it, I guess, right? So, of course, what happens in a normal supply chain security, you guys are developers, you work on the application. Okay, great, I write my code, it's fantastic. Bang, I'm going to commit it. Great, fantastic. Normally, you commit it to some sort of CI/CD pipeline, where you do your tests, you do your tests, your regression tests, and so forth. This is the first stage where you should actually, if you're thinking about it, this should be the previous stage. We should actually start checking for vulnerabilities. Except I didn't say here because we don't have a product that does this, right? So we don't inspect the actual code, right? That's you're actually building. Snyk does that, for example. So this is the first stage where you should actually say, okay, let me go and run tests on my security checks on my CI pipeline and say, yeah, okay, well, this is not going to pass the build because it's got some high-level severities that have been known for the past 30 days. So, Mr. Developer, go back. If you want to deploy your application, make sure that this passes. Okay? Let's say that it all goes well because you guys are all great. Everything gets developed properly. The build passes. It goes into a registry. Once again, these images are there. Okay, great. They should be scanned. They should be scanned continuously. Because obviously, if you've got some sort of application out there that's ready to be deployed into your production environment, you can say, okay, a CV has come out. So you don't want to actually use this image again and deploy it to your production environment. It doesn't make sense. So that's why the constant scanning is important. So private registry is okay, your images are fine, you get up to the admission control. Maybe fine, maybe not fine, doesn't have to be fine. you get admission control of Kubernetes. And then you can tell the admission control of Kubernetes, okay, right, I'm allowed to deploy this app because it's free of vulnerabilities and compliance issues. Or maybe I don't want to let this application because even though I don't want to let this application because it's got high severity issues that have been known for the past 30 days. Okay, so I'm going to block it. Or I can let it go through as well. So you've got all these different hooks into the admission Kubernetes API admission controller to actually allow you to do this. Right? NewVector also has that, which goes a little bit beyond the native Kubernetes API. Questions so far? I'm going to ask questions at the end, so make sure you pay attention. Okay, so we've just seen how image scanning is important, and you should really be doing this today. I hope you're doing this today. As you can see, you're going to gain lots of obvious benefits from it. So, and of course, image scanning, there's lots out there, as I said, there's lots of products to actually do this. Some are open source, some are commercial, right? Which obviously maybe leverage different CVE databases, right? And every product should have its own CVE database that updates on a daily basis, for example, that the vendors actually say, okay, this is my CVEs, this is my vulnerabilities today. As a matter of fact, I highly recommend that you don't just use one scanning software. You should use multiple. Because basically, there's not one real source of truth as far as scanning software is concerned, right? So the more you actually have, if you have 2 or 3 or 4 running, then you can actually get results and then find out that potentially, okay, this result is here, this result is here, which one, you know, maybe they have to complement each other. So I'm not trying to sell you the product, I'm just telling you, use several scanners because it's going to be of potentially more benefit. So, scan is good, but definitely not enough. So you need something than just the image scanning. You also need to protect against the unknown. As I said before, with CVE came out, no fixes as yet. And which brings us to runtime security. And runtime security, once again, you can also split it into 2 different boards, let's say. You got on the left, the threats that you know, which are the threat-based controls. Threats that you know, meaning threats that you have known CVEs that the vendor has actually supplied with you, right? Okay. Scanning for known CVEs, preventing data loss, known data loss protection as well. Web application firewalls, network attacks like, for example, access SQL injections coming into your containers. And of course, the OWASP top 10 and relevant admission control. So it's good, it's important, you got the threat base, but let's look at the zero trust itself. So on the right-hand side, we've got, NewVector has these zero trust controls. So NewVector, and this is the core bit here, NewVector automatically learns the behavior of your application. And this is done behavior at the network level, okay? There is no sidecars at all. We don't use eBPFs, we don't use any file system. So basically what we do, we have a patented, even though it's open software, the patent that we actually connect and interrogate at the virtual switch of the actual node and the machine. So everything's done at network level, okay?
Do you do some baselining then, or?
Yes, I'm going to show you. Yeah, yeah. That's good. He's paying attention. That's good. Fantastic.
What was the question?
Sorry, are you doing some baselining? That was the question. And I said, yes. He's paying attention. I'm going to show you the next screen. Something like that. Okay, so as I said, we automatically learn the behavior of the network, of the application, including the behavior of the network, behavior of the process, of the file access, and the protection rules on each specific container. Right? So look at this, if you try to sort of get your head around this, look at this as I'm limiting my application behavior running on the system, and that's the actual baseline. This is what I actually have. This is what should be running, okay? And furthermore, for example, I could limit the connections a container can make, for example, right? Okay, I can actually do that. I can prevent the downloading of scripts. For example, if an attacker gets into the container, I can actually, of course, if an attacker gets into a container, but if he doesn't have any bash, shell, curl access, he can't do very much, right? So you can actually limit down to that sort of access itself on the container, just in case he falls through, because we all know that security, does everybody remember the movie Shrek? Remember Donkey when he said, life is like an onion. It's different layers, layer upon layer upon layer. That's why I look at security as well, right? So it's not just Kubernetes itself, it all starts coming in, or your network, and so forth and so on. So, I can even, for example, forbid anybody looking at the /etc and /password, if even somebody gets access to the container, right? So it's not just doing activities, but even looking. So with this learned behavior, what we have, let's call it, from now on, typical work patterns, and you're going to see after. Then we're able to generate security policies, which become security as code, which you then can use in your CI/CD pipelines, for example. Okay, so you can already start building this on your pipelines as you deliver your applications, right? So everything built in. YAML files, I can show you what it looks after. Yeah? So you can put it to, do your GitOps approach, to your other clusters, pipelines, so forth and so on. Any questions so far? No? There's no questions. Okay, so let's look at exactly what we're actually doing in NeuVector. So, as I said, we're looking completely at the network's stack level. And we're using live traffic to learn all these network connections that we have. So we've got east-west traffic, normally within the cluster, for example. See what's happening between your specific pods and containers. But it's also looking at the north-south traffic. So north-south traffic is not just something on the internet coming into your application in-house. It's also your intranet itself, or maybe other clusters themselves. So even in this case, other clusters are north-south traffic as well. So traffic coming in and traffic going out. And because NeuVector uses, and this is what's important, the network is the sole source of truth. Nothing else matters. So the network traffic is what generates, this is what my environment should look like. Because we see all this at the network level, we see all the connections, then we're able then to say, okay, we ensure only these valid connections are true, including the process and file usage and so forth and so on. This is probably my last slide. Okay. Oh yeah, deep packet inspection. We have deep packet inspection, and I'm sure there's going to be questions after us about this, as there always are. Deep packet inspection, we actually see what's actually running over the connection. We actually can see which protocol and port is being used between this pod and this pod. Is it an HTTP connection? Is it a MySQL connection? And NeuVector can then ensure that it learns that there is a pod-to-pod communication running on certain protocol, as I said. And it can even detect or say, this looks like Redis, and therefore, the only connection that should be running there should be Redis. If anything else, like MySQL comes in, for example, sorry, it's not allowed, because it automatically learns this is what it should be like, and nothing else should come in. Let me have a look. Okay, good. Oops. Did it change? Yeah. Okay. Other things that are covered by deep packet inspection, I'm not going to, you guys can read. I mean, I can even make this. I'm not sure if you make this available to the CNCF type thing. Do the people get access to the PDFs if they wish?
Oh, absolutely.
Okay, great. Okay, yeah, good, fantastic. Yeah. So I'm not going to bother you with too many details. So because we know, we've learned our application now from network stack, we can actually now start blocking zero-day threats, okay? So if some threat comes in, I'm sorry, it's not going to be allowed. And I'm going to show that in the actual demo where we're introducing alerting and blocking, okay, of traffic. And of course, with the packet inspection, we can start looking at, for example, what is it? Data loss prevention, right? Data loss prevention, everything that looks like a credit card information. Maybe you're not expecting any type of credit card information to leave or to come into your specific containers. You can actually start blocking that because we do that deep packet analysis, and we'll show you after as well. So, naturally, you guys are all cracks. You can go and build all this by hand, right? But why should you, right? It's complicated stuff. It's really complicated stuff. A good container security system, such as NewVector, that was my thing, can assist here in an automatic way. So in NewVector, the complete clusters, so this is the cluster here itself, 3 nodes and several pods. There are 3 different modes. The first one is the discover mode. No prizes for guessing what discover means. So basically, this is where the cluster is put in the discovery mode, which, by the way, is the default when you install NewVector out of the box, okay? It has no impact on performance. I know that question is going to come up, so I'm just going to get that one out of the way. And it's not going to destroy anything. Basically, you're just discovering your environment. That's all you're doing, okay? So we learn all about the network, the process, and file access rules, behaviors, fully automatic, and then you can create the security rules based on this cluster already. Because maybe you just want to have my discovery data available, that maybe you want to then export it to another cluster, for example. This mode is typically runs for, let's say, 2 days, 3 days. In a normal staging, normally in a staging environment, which should be like a copy of production, right? Okay, so you can start learning about your application, right? You don't want to run the discovery mode in the production environment, you know, because obviously production environment should actually be having some sort of level of security before your applications go down there. Then we have the concept. Good. Then we have the concept of zero trust. And this is the monitor mode. So what actually happens here in monitor mode? You do the discovery of the application. Everything looks good. Okay, no problems. This is what my base rule set should, all my rules are looking good. And I'm going to put this in monitor mode. So monitor mode implies that we will be alerted, but not block any suspect activity that you haven't got in your rule set before. It's going to make a lot more sense in the demo, yeah? Which basically is things that were detected that weren't in discovery mode. Once again, this applies to namespaces and the actual pods. You can do it by namespace, filter by namespace, filter by pods, filter by specific names, yeah? Of course, you can still add new rule sets just because something's been learned. Maybe that's what I said. Maybe the scanner didn't pick up something of your internal application. You can go and define at my application banking whatever, runs on port 1305, for example, okay? So you can actually teach the tool, okay, of what it should be learned. Once it's there, set it to monitor mode, stopped. Then we have the protect mode. And this takes the previous monitoring mode to another level. So here, we're not just alerting, we're also blocking the specific traffic. Okay? So even if an unauthorized access is reached to a container, they can't do much more inside a container apart from the rule sets that you've actually have deployed before. Once again, NewVector architecture, no sidecars, no IP tables, no VPF, no need to modify your code. You basically, I really wish everybody goes away, installs it on their laptop, right? Okay. Now, action time. Okay, thanks for the demo. Any questions? Do come around again, please. So, no questions so far? Okay. No?
I'm I mean,
I should wait, yes.
because you say that there's no impact on the performance, but I guess the way it works is you have a pod on every single node, right? Which has dedicated resource and limits. So
Yeah. So what you have,
requires
yeah.
request on
Yeah, I'm negligent. So basically the product, is it recording again? I can show you the architecture if you actually so wish, right? But the way that NewVector works actually, it's a deployment, stateful set, right? Okay. And you have got this concept of the controller pods, which is the only one that actually talks to the API. And this does all the work, right? Then you got the enforcer pods, yeah, that actually do the actual enforcing of block this activity. That's the one that actually takes the time, okay? Because at the end of the day, okay, still, it's going to use some sort of CPU, of course, but we're talking about impacting on the performance. It's two different things that I think we should segregate. So you got the enforcer pod, which does all the work. This is the one that takes up to 2%. Then you got the controller pod that actually talks to the API, and we got the scanning pods that actually does the scanning on a regular basis, nightly. You can schedule it whenever you wish, right? And you got also the web UI, which basically is the web UI pod, which is basically the pod that I'm going to show you in NewVector. And this basic web UI pod is the one that's actually available for you to make API calls directly from without using the actual tool.
Well, I guess it's optional, right?
Yeah, exactly. Well, UI is optional, but you're going to love it when you see it. You're going to love it when you see it. You want to use it.
Yeah, but if you have others in one place, like Observability stuff, whatever,
That's
going to introduce second or third fit tool, right?
Okay, potentially, yeah.
Basically, two questions. First of all, mutual TLS.
Mutual TLS?
If you inspect the network traffic,
Not sure I understand the actual question.
if you encrypt the whole communication.
Yeah. Well, the encryption is something, if you encrypt, right? So first question about the encryption format, right? So first of all, this encryption comes from your actual applications itself, not from NewVector, okay? NewVector cannot go in and break TLS it cannot do that.
But what do you lose?
Well, you actually lose, if you actually do point-to-point communication with your pods, then we can't actually break that sort of the TLS. If he goes between that and, I don't know, Istio, for example, yeah, you can actually go into that if the communication is not encrypted.
And the second question, you inspect behavior, but what about autoscaling, for example? Unexpected autoscaling.
That's a different tool. Okay, so this is a container security tool, okay? It's not a Kubernetes management tool.
No, it's clear, but you have autoscaling in your cluster, in your environment. And it may be a certain kind of scenario which is unpredictable, maybe? Is it an issue in this? Because then you have different connections, maybe.
So basically what you're actually saying, if your cluster...
I mean, you had those pods and...
Yeah, okay, yep.
between those pods, but if you scale...
Okay, well, but your application is still running. It doesn't matter on which node, right? Your application is still running. Your application is still your application code, regardless if it's running on machine A or running on machine C. So we're looking at this at the cluster, within the cluster context.
Okay.
Do you want to keep going, or should we talk about this after the...
After.
Yeah, okay. So if you actually auto-scale, for example, a node, if you actually scale, okay, automatically the Kubernetes detects as a new node in, and we actually deploy NewVector as a daemon set. So basically, whatever needs a scanner needs to actually run on this node, an enforcer is going to automatically run on this node as well. And same thing, but we go about this after. That's okay. So as I was saying before, we're going to use your boutique application again. It's quite boring, isn't it? Done. Okay, so I think we've all seen the boutique application. We don't want to go into it too much. It's just a shop application. And here I've got a cluster. I'm using Rancher because I can, because it's, because I can. I'm using it. And Richer Kubernetes Engine version 2 running on Azure. It doesn't matter what Kubernetes choose you, as long as it's CNCF certified, then it runs. The UI is going to look exactly the same. Not this one, the one I'm going to show you after. And of course, it also runs on OpenShift. As a matter of fact, a lot of customers, majority of customers are running on OpenShift, to be true. So, I've got lots of applications running here. And I've got NewVector as an application as well. And as I said before, when you actually deploy NewVector, just as I have, it automatically does the discovery. I've got my dashboard, not going too exciting here, but I think what I actually want to go through the actual scanning part facilities, okay? Right? Not from the supply chain, okay? This is from the runtime component scanning of the applications. So here I've got the visibility of my platform. It's Kubernetes Rancher. It's a new version, newish version. And as you can see here, does it work if I do this? Yeah. Let's put it this way so everybody can see. Okay. So there is no specific compliance issues or vulnerability issues on my cluster. So you can see the auto scan here. So when I deployed it, automatically do auto scan. And if I'm looking at nodes now, you're going to see that I've got 3 nodes supporting my, my cluster. This is the version, maybe I should use less as an OS image, but this is Ubuntu. And the reason why I chose this one, is, for example, is that we have lots of vulnerabilities here. So this is actually done through a scan. You can scan as often as you wish, okay? On the registries, potentially not every day, of course, if you've got lots of registries, but on the nodes, the scanning through a cluster, it takes no more than 5 seconds. I kid you not, okay? And here, for example, I've got a list of my vulnerabilities. So here I've got my CVE. I get a pop-up here to say that there is an incident. I can actually click and go into the vendor to get the CVE information, if so wish. So let me close this one. So this is the vulnerabilities, that's the CVE based. And then also the compliance risks. And these are actually based on compliance standards like, this is scanned with CIS, which then has things like, the NIST compliance standards, HIPAA standards, the PCI standard, GDPR standards. So it also shows you a list here of the warnings, yeah, and what it should actually be done to fix this on the specific node. Note that this is actually based, this is not Kubernetes itself, this is the software packages installed on the node, okay? So when you deploy whatever, app install, whatever it is, right? Then we've got the level of the containers. So here I've got all my containers running on my cluster, and it's a bit daunting, for example. So let's go to this boutique application, the recommendation server, for example, and here I've got my recommendation servers, and I can see that I've got on this container, right? So this is the pod on top. These are the 2 containers because I'm also using Istio on this pod, sidecar. And here I've got also the same type of context, right? I've got the CVEs. I can see the CVEs on this, and this is at the container level. So once again, I can click and off it goes. Great. And I can also have a look at the compliance type perspective. And here, for example, I've got it's a Docker image. Oops. Docker image, and it gives me an idea what actually, does it come out okay? What you should actually be fixing, right? So that's the container level, and I'm going to show different views, right? Because I'm just showing one container here out of all containers. Of course, I've got my registries. I can go and create my own registries, naturally, okay? And you can actually go and do scan the layers, and I'll show you what scan layers actually implies. You can create your own registry, as many registers as you wish, and you specify the periodic scan that you so wish. If I'm looking at, let's say, Nginx, for example, this one's always very buggy. If I'm looking here, see, I've got a list of the vulnerabilities, alert, and warnings. If I click on in this actual image, it does a deep length scanning. So basically, it goes into the actual image and tells you exactly which error it specifically is, with the CV on the right-hand side. So I think it's actually quite handy from the tool that you can see it at a glance without using Google all the time. Apart from this view, like for example, let's look at the registries, right? So for example, you've got this here, okay, but maybe you don't want to use the UI all the time to find out this stuff. Well, you can actually have a look. You can have a look at security risks, at notifications, and then you got these risk reports. And the risk reports basically is a collection of all the events, right, based on the compliance of certain containers. And this list is huge, right? This list, of course, you can print it, PDF it, whatever you wish. NewVector's got webhooks in order for you to send mail, Slack, or anything else like that, right? So you can send it out, because obviously some auditor people, if you've got auditor people, they don't want to look at the UI, they just want to look at the report to see if they're compliant or not, especially when auditors come around. So what have I showed you so far? How am I doing for time? Good?
5 minutes.
Oh damn. Okay. So this is the scanning part, not very interesting. So let's have a look at something a little bit more interesting, right? So let's have a look at my containers, and this is the trust, the zero trust. So let's have a look at my recommendation servers. Recommendation server. And here I can see that my servers, these are my process file rules. Please pay attention to this. As you can see, there's no wget. I've also got these network rules that have been discovered. As you can see, it says this container to the other container is running on this type of protocol and running on this port. Okay? That's great. So, you remember, process file rules, there's no wget here. If I'm going back to my workload, and if I'm looking for my recommendation servers, right? Oops, recommendation servers. What I'm doing is I'm going to shell into it. So kubectl exec, that's what I'm doing, right? And I'm going to do a wget. Get Google. Oops, google.com. Okay, successful. If I'm going back now to my groups, I can actually see process file rules. I've got a wget there. Fantastic. If I'm looking at my network rules, I should have, with any luck, I should have an external. I know it's in there somewhere, but now we're running out of time, right? But I know it's in there. We've got the there it is, okay, at the bottom. See, I'm not lying. So basically it detected the wget as a process rule, and now I've got also my recommendation service made an exit to external via HTTP, right? Great. So that's all great. So what I want to do is go back to my recommendation service, which is here. And all I want to do is I'm going to switch the mode to monitor. Okay? I'm going to switch it to monitor, just like that. So now I'm happy, but then I realize, oh darn, I didn't want this wget. This should not be in there, right? This should not be a rule I should be able to allow. So I'm going to here, I click wget, and I'm going to delete this rule, and it's gone. Okay, it's gone. The network security rule is still there, right? So now I'm going to do wget google.com. It works, of course. I didn't block it, naturally. Let's go back to the actual NewVector itself, and I'm going to go for notifications, and I'm going to security events. Oh, there you go, process violation rule. It's found. Straight away, a violation on it. Okay, that's what we want. Fantastic, right? So, I can click on the rule, but I don't want to do that. Now let's go back into it, and let's, sorry guys. I'm not allowed 3 more minutes?
Okay.
Okay, thank you. Oh, damn.
Feel the power.
Feel the power. If I'm going back to my groups again, if I go back to my recommendation service, and now I'm going to switch this mode to protect, right? Okay, it's gone. If I go back to my wget, sorry, cannot be done. Of course, because I've actually disabled it. All right, fantastic, great. So I go back to my security, I'll go back to my my security events, and I go, look, here's my critical event here. But I can go, oh damn, I did something wrong. Okay, this should be allowed. So I can go and deploy it again. So the wget now, if I go and do it, it's going to work fine. As a matter of fact, it's going to work fine because I'm going to do something to add on because we're running out of time. Remember we had got this external rule in place, right? So what I want to go into my policies, groups, if I go into the groups, if I go to network rules and I'll look for recommendation service, which is the external here at the end. I need to get new glasses, by the way. You can't help me, but it's true. And I'm going to remove this rule. I'm going to save it. Very important to save it. Good. Now, let's have a look. Is this going to work? Yes, it's going to work. The wget works, but the external connection is gone. Right? I can no longer connect, right? Okay? So I can do, but I can get access. Okay, fantastic. Last 2 minutes. Last things I want to show you quickly. Last 2 minutes. I get excited. I like the software. Here, this is also a different view, right? Or you have. So here, basically, I've got a topology. That's what I'm looking for. A topology on the actual tool. It's quite messy because I've got a lot of stuff. But all I want to do is I'm just going to do a filter by shop namespace. Yeah. And I'm going to apply. So I just actually see my my application, all these different microservices as you've shown before. So as you can see here, so this is great. So I can see that I've got, if I click on that, I've got 8 medium. So every blue circle is an actual pod. Okay, every blue circle is a pod. And this is really great because as you can see, and these all the line communications. HTTP, for example, I can click on that. Oops. Oh, okay, doesn't matter. But you see this red line? This red line, basically, it's the line that's actually saying access is blocked from my recommendation servers to the external world, yeah? So this is just a view. From here, for example, I can also right-click and, oops, okay, that's crap. Here, I'll click. I can actually change the mode as well. I can go to monitor, protect. I can even quarantine the pod, meaning take it completely offline because there's a big DDoS attack going on. Block it completely, take it off. Or, better still, if I want, because you're using deep packet capture, I can actually do a packet capture. So this is a really great tool. So you can actually, really an add-on, right? Because we're doing the deep packet inspection. We actually do a deep packet inspection. We're actually recording the traffic, okay? Then I can actually say it's running. Okay, let's stop this, for example, and then I should be able to download the file and view it in Wireshark, for example, so you can see all the packets that are actually going on, already embedded in the tool. Time's up.
Beautiful.
So, we didn't go into web application firewalls, DLP. You can create your own WAFs, you can create your own DLPs, block internal, external. There's a lot to show, but only 30 minutes, so good. Any questions now or after? I'm there. I'll take you up on yours after. Thank you all.
So, you know me already, no need to introduce myself, so who does backups? It is interesting to do backups. Sometimes it can be useful. And this is exactly what KDAP can help you do. So this is the mandatory marketing slide about Vision. We are 46 Visioneers. We are 5 in Vancouver, Canada, 46 here in Zurich. And we are the leading DevOps, Docker, Kubernetes, and OpenShift partner. And that's why we created an office in Canada. This is actually something very new. This allows us to follow the sun. We follow and we work with a large range of companies, and we've got 3 products that we're very proud about: Apuyo Cloud, Project Sin, and KDAP. So tonight we're going to talk about KDAP, of course, and a little bit about Project Sin. So what is KDAP? So first of all, you have to know what is it and how do you pronounce the name. So you can say KDAP, but there's another way to remember the name of the project, and this is very simple. You can just say ketchup. That's another possibility. You can use the word ketchup to describe KDAP. And what is KDAP? KDAP is backup as a service. This is basically what it does. So what is KDAP? It's a backup operator for Kubernetes and OpenShift. We've been using it internally since 2018 for 5 years now. And it wraps Restic. I don't know if you know Restic. Restic is a backup tool. For those who don't know, Restic is literally a time machine on the command line. It's a wonderful tool that is compatible with Windows, Linux, and Mac. And I use it every day to perform backups of my systems, my personal and my work computers. It works incredibly well, so it's highly recommended that you check it out. So KDAP, what it does is to wrap KDAP, to wrap Restic inside of the operator. We've released the current version 5 days ago, and you can find all of the information on kdap.io and on GitHub, of course. But there's one thing we're super proud about, which is that the CNCF, the Cloud Native Computing Foundation, has actually selected the project to become a CNCF sandbox project. So that is something that is really something we are super proud about. The first question you gotta ask is, where does it store backups? So usually S3 compatible backends, and actually KDAP writes backups anywhere where Restic can write backups too. So usually S3, it's a very common target for backups for KDAP. How does it work? Well, KDAP will back all the PVCs in the same namespace. And how does it work? How do you make it work? First of all, you create backup credentials. So you need a password to store your Restic backup. Then you trigger backup or set up a backup schedule, and there's no step 3. That is all you need to do to use KDAP. How do you tell a PVC to be backed up? Well, there's an annotation, kdap.io/backup. You have to specify that annotation, and KDAP will automatically pick it up and back up the contents on the Restic repository. Then you need a password to store that, because Restic encrypts the information of your backups. It's very secure, so you need a password. And as you can see, I've chosen a really secure password here to show. So I'm following what Claudio was saying in this previous talk. And you can specify schedule objects, and schedule objects automatically will trigger a backup with the frequency that you specify, and you use the cron syntax. So as you can see on the slide, here we are very paranoid. We are specifying a backup every minute. The important thing of this configuration is the backend object. You can see this backend object in the middle that contains the URL of the S3 bucket where you're going to store the data, the access keys, and the secret access keys provided usually by AWS. So this is a small object that you are going to see everywhere in all of the configuration files used by KDAP. Now, the important thing about a backup is to know whether it can be restored. So the reality is that you don't know if your backup actually exists until you've tried to, or you attempted to restore. So of course, there is a restore object available in KDAP. The restore object triggers an immediate restore operation. And the only thing you have to specify, apart from the well-known backend object that we've seen previously, is the folder in your persistence volume claim where you want to restore the data. You can also restore the data using restig. So the repository used by KDAP is literally a restig repository. So you can just use restig on the command line to operate and maybe to restore data directly on your laptop. So this way you can investigate and see what is being backed up, and even restore it on a different system if you need to have some kind of staging cluster where would you like to see the state of your applications. Another interesting thing that we can use in KDAP are pre-backup pods. So the idea behind pre-backup pods is the following. Not everything that makes up your system is stored in the same cluster. So you might have, for example, databases that are provided by an external provider that are outside of your cluster. So how can you access them? How can you back up them? The problem being that, of course, they don't have PVCs. Their data is stored somewhere else. So a pre-backup pod will run before the backup and will connect to that system and will trigger an operation that reads information directly on standard input. Anything that is written on standard input can be read by restig and by KDAP and will be automatically backed up in your KDAP backup repository. So this is a canonical example that you see here. We are using MariaDB and basically we are writing a MySQL dump. So everything is very nice, but it's much more interesting. It's much more interesting to show a demo about what we're doing. So for this demo, I have a very simple system. What we have is basically a WordPress installation with a MySQL backend. So there's a database and the WordPress installation with a persistent volume claim. But the persistent database is running outside of the cluster on exascale. And we want KDAP to back up both the PVC of WordPress and the MySQL database running on exascale, right? And we want to save everything into a restig repository that will be available on an S3 bucket, also in exascale. What you see right here is part of the AppCat system. We are building this open source system, which is compatible with various Kubernetes, including OpenShift. And this system allows developers to request and provision databases, message queues, anything that they need for their applications to run. Right now, we support S3 buckets on both exascale and cloudscale, and databases of various kinds on exascale and Postgre databases on cloudscale. But we're working to expand this for many, many more systems in the future. Thanks to the object that you see on the screen, I can specify an exascale database as a service of type MySQL. And as soon as the thing will be created, as soon as the database will be created, the secrets, that is the connection secrets for this instance, will be installed in my cluster in a secret object. And what I've done previously while Claudio was talking was to request this database, because the request of this database can take up to 4 minutes. So I wanted to gain some time. So now I'm typing OC get exascale MySQL. And as you can see, the database is ready. The connection secret is already available on my cluster. It's called MySQL creds. So I can use that to interact with my application without actually even knowing what this password is. And this is very convenient. Right now, what we are going to do is to deploy WordPress. So it's a very straightforward deployment, right? It's the usual Bitnami WordPress latest image. And we have all of the values that come out that are required by WordPress, including the block name, are defined as environment variables. Some of them, some values are coming from the secret. Then we need a service. We need a persistent volume claim, of course. And this one has the database the KDAP backup through annotations so that it will be picked up by KDAP to be backed up. So this is very important. And finally, we have a route because we want to access this WordPress so that it is visible on the outer world. So now I can just OC apply -f WordPress YAML, and boom, I have my WordPress being installed, and I see the route already available and created. So let's go to the browser. Let's see if I can open it up in my browser. If I hit enter on the URL, well, the application is still not available. I refresh, now it is available. So I can do to WP admin, and this is the user and the Bitnami password. This is the default password in that image. You should change it, of course. I haven't changed it. It's just for the sake of the demo. So I'm going to use this WordPress. This is live, as you can see. I can see the blog. It is actually working and it's really cool. What I need now is to go to the console, create a new post, and I like doing these kind of things to show that these things are actually working. So let's add new post. I will do this live on the CNC Meetup, the CNC Switzerland Meetup, and I'm going to add an image. And images are very nice on blogs. It's very important to have image. And I have one that is called image JPEG, and it's very appropriate because it's literally a hard disk. We are talking about storage here, so this is very important. There we go. The blog post is published, ready to be used. So I go back to my editor, and first of all, for my backups, I need a bucket. And I'm going to use AppCut to create that bucket. And I'm going to create that bucket again on Exascale, right? AppCut right now is working on CloudScale and Exascale, but it will be available in other providers in the future. I give it a name, and I specify the region CHGVA2. That region name belongs to Apuyo Cloud. Right now we have two zones in Apuyo Cloud. One is Lübfig in Canton Aargau, the other one is in Geneva, in Canton de Genève. So right now we are doing this whole demo in Exascale in Geneva. Then what you need to do is, again, OC apply, bucket YAML. Boom, you've got the YAML. So now if I check if my bucket has been created, object bucket, the bucket has been created and it's ready. The creation of object buckets is much faster than the creation of databases. Now, what we can do is to create our pre-backup pod. The pre-backup pod is exactly what I've shown on the screen. There's no difference here. It's a pod that will be run by KDAP to gather the information inside of the database using the MySQL dump command. So this is why this container contains this backup command. I use the same parameters as the WordPress application, and as you can see, the image below, it's the MySQL image. The MySQL image contains the MySQL dump command, so I can just use that. So once again, OC apply -f pre-backup pod, very good. We've got our object running. So now what we need to do to install KDAP, and not install KDAP, but actually specify what we want KDAP to do. So the first thing we need is, of course, the password to the restig repository. And that's exactly what you see right there on the screen. It's the famous super secure password I just talked about. Then we have a schedule object. It's a schedule object called schedule test with the famous backend object information. And the backup schedule, I'm doing it every 5 minutes. It's still a bit paranoid, but it's good for a demo. And we've got a backup object. The difference of a backup object is that a backup object is triggered immediately. There's no scheduling. That's why you have the schedule object. So why do I do this? This way, when I submit this file, when I apply this file, I will have a backup immediately, and I will have a scheduled backup every 5 minutes. So once again, OC apply -f backup kdup.yaml. So let's see on the cluster what is going on. So unfortunately, I cannot disable, it's still on night mode, my browser. I cannot disable the night mode, so it's a bit dark, but I hope you will be able to see. I have a project called CNCCH Meetup, and if I see the pods, we've got already running the MySQL dump pod. It's running an idle waiting for be executed. And now, boom, you can see the backup project. So let's zoom in a little bit the interface. And what's going on is that the MySQL dump pod is actually connected to the database and retrieving the MySQL dump. And this is being driven by the backup object that you see on the screen. That guy is actually driving the whole operation and will gather all the information from the pre-backup pod and from the PVC, from the file system of WordPress. And this way, it will take all of this information, it will create a RESTIC repository on the S3 bucket and make that backup using all of these pieces of information. So it is running. So the whole process can take a little bit of time, but while we do that, it's important to understand what the pre-backup pod is doing. The pre-backup pod is sitting idle on the cluster with the capability of performing a backup command, but it waits for KDAP to wake up and request for a backup. At that point in time, the pre-backup pod wakes up, executes the backup command on behalf of KDAP, and then KDAP gathers that information and uses it for the backup and stores that through RESTIC on the backup repository. This is the logic behind the pre-backup pod. Now that we have executed this backup, we can actually use RESTIC on the command line. And for that, I need a little bit of information. The RESTIC command line is able to use a certain amount of specific environment variables, including AWS _access _key _ID and so on, and RESTIC password, of course. And once you export all of those things, and for example, in this case, I'm going to source this environment.sh file, I have all of those variables, and now I can ask RESTIC for the current snapshots. The RESTIC application stored in my laptop that I use for my backups is able to connect to that S3 instance using the secrets and using the access keys, and will open up this repository using the RESTIC password that I provided, and will tell me that these are the latest snapshots. These are the only snapshots available, so on. And each snapshot in RESTIC is identified with a specific ID. And this is very interesting because I can use that ID to perform restore. So I'm going to use RESTIC restore -- target dot. So I want the restore to happen in this current directory. And I just specify the hash. And now I have the snapshot. And as you can see, I have a new file called cnc-meetup-mysql. And it is the dump of the database used by WordPress. So I can do the same with the PVC. If I do the restoration of the WordPress persistent volume claim, I'm going to have the whole full system, the whole tree of files used by WordPress, including the plugins, the images that you've uploaded, and everything. And this is basically the demo that I wanted to show you. This is KDAP in action. There's not much more than that. There are a few other features that could be interesting for you guys. First of all, you can back up all of the PVCs in the same namespace. So you just specify the PVCs with the required annotation, and it will be backed up by the schedule object and the backup object. You can have application-aware backup. So if you have a pod running MySQL, you have MySQL running as a pod inside of your cluster, you can use an application-aware backup, which is very similar to a pre-backup pod. You can do RESTIC checks to check for the data sanity of a repository, and you can schedule that to happen every so often. So this is a very interesting feature. It allows you to make sure that your backup repository is safe and has not been corrupted. So this is very, very, very important. You can schedule that as well. And there's an archive feature. So for example, if you would like to send an archive of your backups to, for example, AWS Glacier, you can tell KDAP to do that in a certain frequency. And we use KDAP as well as the default mechanism on Apuyo Cloud. So that's why it was so easy for me to use it, because I was running this demo on Apuyo Cloud precisely. And everything that has to do with Apuyo Cloud, in Apuyo Cloud, we've got literally this operator installed. Now, application annotation aware backups is an interesting feature. I just mentioned it very quickly. I'm not going to dive deeper into it. What is coming up for KDAP? So we have a full roadmap for this product, and this is very interesting. First of all, today we've released 2.6 release candidate 2, and it contains the single most requested feature for KDAP, which is the backup of RWO, so read-write only storage. Right now, you can only backup read-write many storage, but for years, the most asked capacity was to have the possibility of backing up read-write only storage. We are planning a KDAP CLI where you could literally on the command line KDAP backup, KDAP do this, KDAP do that. Probably as a kubectl plugin, we are still working on it. We want better visibility for backups. So for example, to have the list of available snapshots directly in Kubernetes, for example, kubectl backup list, something like that. And of course, have some usability improvements, for example, to specify which containers to run backup. So like you would have some kind of tighter control on the backup commands that you are scheduling. So for example, right now you schedule a backup and the backup will be in all the PVCs, maybe you just some of them and so on. This is an open source project, so do you want to contribute? Thank you so much, please do. You only need to go to GitHub, you need Go, nice IDE with a Go plugin, could be Golang, could be Visual Studio Code, we use Visual Studio Code. And of course you need Docker, you need Make, and we use Kind as the cluster where we do all the testing and the development. So you need Kind installed locally. But KDAP works with pretty much every Kubernetes that we found around in the world, from OpenShift to Rancher to Amazon Kubernetes Service and so on. Another interesting news is that KDAP will be present in a booth at the upcoming KubeCon. So please, if you are in KubeCon in April, come say hi. It would be great to see you there, April or May, I think. Please just come and say hi. And that's everything I had for you today. I hope you like KDAP and I hope you will use it and that it will be useful to you for your backup needs. Thank you so much.